Hello everyone. So welcome back. We're doing analytical geometry in this chapter. This is the first video, which will just be under. This is just revision from grade 10. So, yeah, everything in this video it's just a revision from grade 10. But in case you've forgotten certain things, let's get started. So, in our diagram, we have a Cartesian plane with a couple of points A, B, C, D, and I also just made sure that x values correspondingly, like the signs corresponds to the quadrant. Yeah. So for an example now, point B. What is this? Okay, wait. Okay. Yep, so we have a point there, point B, and right here this is our angle theta, in this direction, of course. And what about this angle, right? Maybe before that we can talk about a few things. This line over here, from the x-axis to B, this is just gonna be our change in y, right? And from here, the origin up until this point, that is gonna be our change in x. So yeah, these are just minor things. So now one thing to remember is that we have Pythagoras theorem, we have distance formula, we have the gradient formula, right? Pythagoras theorem is, in a sense, if you have a right angled triangle, yeah, maybe let me give out a proper one. So you have your right angled triangle, and yeah, so with your right angled triangle, this is A, this is B, this is C. It's known that B squared is equals to A squared plus C squared, right? So how do we apply how are we going to apply the Pythagoras theorem on our Cartesian plane in analytical geometry? So we already have point B there. Say this is point P, this point right here, and say the origin is point S, right? Yeah, so in that case, our theorem is just gonna go like this. It's gonna be I don't know which color to use. It's gonna be BS squared. It's gonna be equals to SP squared plus BP squared, right? But now we know that BS, SP, and BP, they are all distances. The distance between BS, distance between SP, distance between BP, those are distances. So we need a distance formula to get those distances, and then after we have the distance formula, we can just calculate the distance formula, put our squared values, and yeah, we have it. So the distance formula, we'll just say maybe a distance formula between point A and B is equals to what? It's gonna be square root of, you have, let's start with y1 minus y2 squared plus x1 minus x2, right, squared. Yeah. That's your distance formula. And I mean, you can also doesn't really matter, you can also write it as let's see, you can also write it as y2 minus y1 plus x2 minus x1 squared. The answer is still going to be the same. Yeah, the answer is going to be the same, nothing is going to change. So you use this formula, any of them, and you use this formula for this, for this, for this, and you have your Pythagoras theorem. Yeah. Then the last thing on this page is the gradient formula. right? Which of course the letter we choose to represent the gradient with is m. Yeah, so gradient formula is change in what? Change in y over change in x. That's the gradient formula. I know back in my time, I used to like easily just make a stupid mistake of saying my gradient is changing x over changing y. That's one of the stupid mistakes I used to make. So just try to always remember the right formula for the gradient is changing y over changing x. So now the question is, what does that mean? Like, what is changing y over changing x? What does it mean? It simply means y2 minus y1 over x2 minus x1, right? Or you can say it's equals to y1 minus y2 all over x1 minus x2. So something here that I should make you be aware of is I started with y1, I started with x1, I started with y2, then the denominator also starts with x2. y1 x1, y1 x1, y2 x2. So just be careful of that. That maybe some trick that can help you remember. Yeah, so that's the gradient formula. Cool. Let's continue. So I drew this table with different graphs, and we're gonna talk about the gradient and possibly why the gradient is like that. So if you have any line on your Cartesian plane that is at an angle, let me say any line that is not horizontal or vertical, right? In simple terms, any line, if you have any line on your Cartesian plane that is not what? That is not your y-axis or your x-axis. Yeah, or maybe parallel to those. Parallel to any of them, right? Yeah, that's the most correct thing to say. Then your gradient is simply gonna be what we were saying. Yeah, simply gonna be changing what? Changing y over changing x. Changing x, which we did say. I'll say y1 minus y2 divided by x1 minus x2. Nah, yeah, it's gonna be like that. Only if your line is not perpendicular, is not parallel to your y-axis or your x-axis, right? So yeah, but look at this one, the horizontal line. If you happen to have any horizontal line which it's equals to y equals to some value a, right? In this case, let's see what's gonna happen. If I try to find my gradient, I have to realize that my y value is the same through all out. We can pick any value of x, my y value is gonna be the same, right? Say for example, in this case, y equals to 4, right? If y is equals to 4, it implies my y is gonna always be equals to 4 all over. So I calculate my gradient, changing y over changing x. Let me not care much about changing x. One thing I should realize is changing 1 is gonna be 0, because 4 minus 4 over changing x, that's gonna be what? 0 over changing x, which is what? Which is 0. So if you have a horizontal line, the gradient is 0, right? And I can ask you now to think about, what about the vertical line? The vertical line, it's simply same logic, but in this case you realize that here we can say x equals to 2. You realize that here x values are the same through all out. So when you do your gradient formula, changing y over changing x, it's gonna be 0, right? Changing x is gonna be 0. It's also changing x. And when you have a denominator as 0, what do you have? Undefined, right? Or math error, yeah, cool stuff. Okay, cool. So as for parallel lines, if you have any parallel lines, any two lines that are parallel to each other, the gradient has to be the same. So if this is line 1 and this is line 2, I know m1 is equals to m2, And for perpendicular, say this is line 1, this is line 2. On this case, I know the product of the product of my gradients must give me -1. So m1 times m2 has to give me -1. That's just, yeah, cool stuff. So I didn't write anything under this the column of why that is the case, why m is the way it is. Yeah, simply I was just, while I was talking about the gradient, I was also explaining why it is that way. But yeah, cool. Let's yeah let's continue to cook. The last thing, or second last thing, is your midpoint line segment. Midpoint of a line segment. So if you have any line, a straight line, if you have a straight line, and on that straight line you have say 2 points, you pick any 2 points, point A and B. Ne? If you want to find the midpoint of point of line AB, you use the formula. You just add the x values of the 2 points from A and B, divide by 2, and take the two y values. Yeah, take the two y values from, from your 2 points A and B, divide by 2. So yeah, basically, yeah. So I can say perhaps here, just in a good example, I can say this is 6 and 4, right? And say perhaps this is -2 and -1, right? Cool. So the midpoint of AB is gonna be, this is x, this is y. It's gonna be, I add the x values, so that is -2 plus 6 divided by 2, and then the y values, I add them, -1 plus 4 divided by 2, right? So I'm gonna have 4/2. I'm gonna have 3/2, right? Yeah, and then my final coordinates, my final point, it's 2 and 1.5. 1.5. So this end up being my final coordinates of, this point AB. This will be 2 and 1. Let me just say 3/2. Oh yeah, cool. Yeah. Now the other thing is, let me see. Yeah, the other thing is quadrilaterals. It's very important for you guys to know this like different types of quadrilaterals. Of course, quadrilateral is a closed it's a closed shaped, that has four sides. Any closed 2D shape that has four sides, that is a quadrilateral. Nicely they gave a definition there. The thing is, with parallelograms, no, with quadrilaterals, regarding your analytical geometry, you have to know the characteristics, you have to know the features, you have to know everything about each quadrilateral, because you can get a question, whether they give you coordinates, and when you plot out those coordinates, they give you a particular quadrilateral, and they can ask you, what is that kind of what quadrilateral is given by this 4 points. You know what I'm saying? So if you don't know the characteristics, you don't know what a particular quadrilateral looks like, it's gonna be really easy to lose marks on those questions. So yeah, you can maybe pause and take some notes here. There's a parallelogram, which is kind of like a rectangle, but it's a bit pushed, and as a result, uh, of course, you have both pairs of opposite sides. They are equal in length, and they are also parallel to each other. That's something that was not mentioned here. Yeah, so they are both parallel to each other. Opposite sides are also they are parallel to each other. Yeah, we also talk about what opposite angles being equal. It's noted there, and the diagonals bisect at each other. And yeah. So so I don't know what more to say on this. Honestly, I don't know what more to say. I'm just gonna be reading what's on the on the screen. So what I say is just take this, note them down, try to remember them, right? Yeah, we have your rhombus, your square, we have your trapezium, we have your kite. So know the characteristics, know what a particular parallelograms, no, quadrilateral, not a parallelogram, know what a particular quadrilateral looks like, so from there it's just easy. And I'll also say maybe try to remember the formulas for your parameters and your formula for what the area. You could easily get those questions as well. Using your distance formula, you will have to calculate the area and so forth, or the parameter and so forth and so forth. So yeah, let's see. I think I have a question that we are going to do. Yeah, so let me just lock this. And so looking at this question now, you have different points. You have P, Q, R, S, and in a Cartesian plane. So before, it's really nice, or maybe it's a bit helpful to draw the thing so that you can easily see it. So I'm gonna do just that. Cool. So yeah, here's the Cartesian plane and what it looks like, having plotted those numbers. Yeah, perhaps I can also put them. So this is P, which is -3 and 1, and this is 6 and 1, which is R, and then Q is 1 and 3, 1, 2, 3, and this one S, it's 2 and -1. Yeah, so now they say calculate the length of P, Q, and RS. So PQ, this is PQ, right? And this is PQ and this is RS. Here is RS, so we have to calculate the length. We're gonna use the distance formula, of course. So for the first question, we'll say distance of PQ. That's gonna be square root of. Just to be safe, I'll write the formula: y1 minus y2 squared plus x1 minus x2 squared. And now substitution. So y1, I will just take it from P, that's 1 minus 3 squared, plus then it's x now, which is -3 minus 1 squared. So that's gonna be here it's -2 squared, plus this is -4 squared, that's square root of 4, and that's plus 16. So this is just square root of 20, which is 2 root 5, right? 2 root 5, remember, like 20 is the same as 4 times 5, which is square root of 4 times square root of 5, which is 2 times square root of 5. So yeah, 2 root 5. So yeah, that's the distance for PQ. Now the distance for RS. Now let me see distance RS, yes, or SR, yeah. So distance for SR, formula first. Then substitution. Y1, I'll take it from S, -1 squared plus -6 squared, then that's -2 squared plus -4 squared. So you see, like now I have minus square root of -2 squared, which I also had here. I have -4 squared, which I also had here. So I can just say the answer is going to be 2 root 5, né? Yeah, so I have discovered that the distance of PQ is the same as the distance of what? Of RS. But I mean, that's not enough yet to maybe conclude on what quadrilateral this is. Oh yeah, we have that question. Yeah. Nice. So yeah, let's keep on working. They say number B, find the midpoint of PR. Here's PR. So remember the formula for midpoint. So midpoint of PR, which is your coordinates xy, it's gonna be x1 plus x2 divided by 2. Then you're gonna have y1 plus y2 divided by 2. Then yeah, you'll be done. This is the formula. So yeah, if I do the math, x1 sums PR x1, that's minus 3. So minus 3 plus x2, x2 is 6, then divided by 2, right? Y values, I have 1 plus, I have 1 plus 1, divided by 2, and the answer is gonna be 3 over 6 and 2 over 2. To write them as like numbers instead of fractions, you're gonna have no, this is 2. You're gonna have 1.5, you're gonna have 1. Yeah, I don't know if you want to leave it like this, but of course here this will have to be 1. You can leave it like this, or you can leave it like this. Yeah, doesn't really matter, but yeah, that's your midpoint. It's gonna be use a different color. So your midpoint is gonna be, this is 2 right here, 1.5 is somewhere here, so it's gonna be somewhere here, right? Assuming this is x equals to 1.5, right, which is 3 3 over 2. Yeah, cool. Let's see the next question. It says show that PQ and SR are parallel. Wow. Yeah, so PQ and SR, firstly we did calculate what? We did calculate the distance, and the distance were the same. Now they say we must show that they are parallel. So I'm gonna copy this diagram. Hopefully, yeah, it will just help me not get lost at all. So let's see the next page. Paste. Cool. So we have to show that PQ and RS are both parallel. So remember, for parallel lines gradients, calculate the gradients. If the gradients are the same, we have parallel lines. Cool. So yeah, I'm gonna start with PQ. Gradient, go black, that's number 3, I believe. So gradient of PQ is gonna be changing y, changing x, and that's gonna be y1 minus y2, x1 minus x2. Now I'm substituting the values, 1 being p, so minus 3 minus 1 all over what? All over 1, right, minus 3, and that's gonna be minus 4 over minus 2, that's gonna be 2, right? Yeah, it's fine. Is it fine? No, it's not fine. It's not fine. Let me just check it. Let me check it. So y1, it's yes, it's not fine. It's not fine. I made big errors, so I'm gonna go slow this time. I'm gonna go slow. So y1 is p. This is 1 and this is 2. So in that case, y1 is 1 minus what? Minus 3. that is fine. y1 minus y2. y1 is 1, y2 is 3. So 1 minus 3. Cool. That's fine so far. And now x1, that's minus 3. x2 minus, it's gonna be, yeah. So now what do I have? I have minus 2 over minus 4. And I have 2. No. I have 1 over 2. Yeah. Whew. Yeah. So, yeah. Be careful also, just not to make the same mistake I kind of almost made, when substituting these. So, yeah. Let's see the gradient. We haven't proven anything yet. We're just going to see the gradient for SR, which is changing y over changing x. And that's y1 minus y2. That's x1 minus x2. Gonna be slow. I'm gonna be slow. y1, that is minus 1. Then I'm subtracting y2, which is 1. Cool. x1 is 2, right? And x2 is 6. So 2 minus 6. Then I have minus 2 over minus 4, which is 1 over 2. What does that mean? So since MPQ equals to MSR, it means that MPQ is parallel to MSR. Then I'm done. You see that? Then I am done, right? Let's see. Now this question here, it says determine the equations of the line PS and SR. PS and SR. Where's PS? This right here, this line right here. This line, that's PS. What about the other one? SR. And SR is right here. This is SR. So yeah, since from the previous questions I have the gradient for SR. I'm gonna start with SR, ne? 4. I'm gonna start with SR. Yeah, so to find, like you have been using this equation, y is equals to mx plus c, and then for SR, gradient is half and plus c. Now I can use any formula, any value, any point. So I'm going to use point R. If I use point R, I have 1 over 2, 6. I'm just substituting point R, yeah. Oh no, this is plus. Then I have 3 plus c, then I have 1, and implying what? Implying that I'm gonna have 1. Therefore minus 2 is equals to c. Therefore y for what? For SR, it's gonna be 1 over 2 x 1 over 2x minus 2. That should be fine. Cool. So now let me find y for what? For PS, ne? For PS. First and first, I can just find the gradient. Yeah, well, mx plus c. Let me find the gradient. The gradient is changing y over changing x. And that is gonna be what? Let's start with that's y1 minus y2, x1 minus x2. If I do substitute, say 1 is p and this is 2, so that means y1, that is 1, y2, that is minus 1, right? And then x, I have minus 3, right? I have minus 3, and yes, minus 3 minus 2. And the question is determine the equations of PS and SR. Cool. So I'm gonna confirm this coordinates and make sure I made no substitution error. So y1, that's p, then minus 1, yes, cool, and then minus 3 minus 2, yeah, that is fine. So that's to say I have 1 plus 1 all over minus 5, which is what? Which is 2 over minus 5. So all I can say is, let me just do this, creating more space. Y for PS is equals to minus 2 over 5 x plus c. Let me see which coordinate I can use. Let me use s maybe. Yeah, let me use s. So if I go for s, I have minus 1 equals to minus 2 over 5, 2 plus c. I transpose the whole thing. I'm getting a positive 4 over 5 minus this one. I can say I have 5 over 5, right, equals to c, then c. This is 1 over 5. That means my y for PS is what? Is minus 2 over 5 x minus 1 over 5, right? And yeah, if I look at the graph, it kind of makes sense. Negative gradient, and my y-intercept is just below 1. So yeah, kind of makes sense. Let's see. They say, is PS and SR perpendicular, right? Explain your answer. So PS is this line, the one we just calculated the equation for. And wait, is that PS? Yes, that's PS. And SR, and here's a line for SR. Here's a line for SR. This is kind of messy square, but yeah. So the thing is, when you look at this line, you're gonna see one thing which is true. These lines are not perpendicular, right? Remember, for lines to be perpendicular, the gradient, product of the gradient, must be -1, right? And in this case, you take 1 over 2 from here, multiply by -2 over 5. From here, the answer is going to be, this 2 cancels this 2. The answer is minus 1 over 5. So the 2 cannot be perpendicular, right? The 2 cannot be perpendicular because the product of the gradients, the products of the gradients of RS and PS does not equate to -1. So that's what am I, that's the thingy. Hey, yeah, I forgot what I was gonna say. Yeah, that's your explanation. The product of the two gradients are not equals to -1, so they cannot be perpendicular. To answer the last question, what type of a quadrilateral is PQRS? To answer that question, what I will say is, let's find the distance. Since we have the distance for PQ, right? Let's find the distance for PS, as well as the distance for, first thing, like, we already know that these two, they are equal and they are parallel. We proved that. So the next thing, we can find the equations, not the distance for distance for QR. You find the distance for QR. That's number one. Number two, find the distance for what? For PS. Distance for PS. And if these two happens to be equal to each other, but not equal to PQ and RS, then it's gonna be what? It's gonna be a parallelogram. Because remember, for a parallelogram, opposite sides are equal and they also have to be parallel. So you can also calculate the gradient of, maybe at this time, since we have the gradient of PS, we can calculate the gradient of QR to check if they are really parallel to each other. And if they are parallel, then it's gonna be what? A parallelogram. But of course, if you calculate the sides of Q, the distance of QR and PS, and the same distance is equals to the distance of PQ as well as the distance of RS, then you realize that all the sides are equal. It has to be a rhombus. You know what I'm saying? Yeah. So with this kinds of question, it goes back to this like you knowing exactly what a kite looks like, trapezium, a square, rhombus, like all these quadrilaterals. You know the structures, the features. You know everything about each parallelogram, each quadrilateral. Damn, I've been saying parallelogram so much, bro. But yeah, you know everything about each quadrilateral. I almost said parallelogram. You know everything about each quadrilateral. So yeah, it's just gonna be easy, man. It's gonna be easy for you to be able to prove. So what you do is, look, for example, say you have a rhombus, né? You calculate what? You calculate for the distance, because they say the opposite sides are equal. You calculate for the distance as well as finding the gradient to check if they are parallel. If that is the case, you kind of know that, yeah, they have to be, right? Yeah. And let's see, the diagonals, they bisect each other. Yeah. So the diagonals, they bisect each other. You see another thing at the right angle, right? So with that, you can do what? You can find the gradient of AC and find the gradient of DB and multiply them together. You have to multiply them together and they have to give you -1 because they are perpendicular, right? Yeah, because they are perpendicular. So that's how you would prove that something is a rhombus. As for, and then of course, here all the sides are equal. Yeah, all the sides are equal. Same as square, all the sides are equal. The sides are also parallel. So yeah, you use the distance formula, you use the gradient for the parallel parts, and you use the gradient as well for the 90-degree perpendicular line of AC, and BD being perpendicular. And yeah, so that's just it. Or you can, that DA is perpendicular to AB. Just the gradient formula, they help you do that. So yeah, and should you have just quadrilateral with one pair of opposite sides that are parallel, that's a trapezium. So yeah, I believe that will be the end of this video, which was just based on revision. In the next couple of videos, we'll be doing grade 11 things for analytical geometry. Thank you so much. See you there, and good luck.